Hi, this is Gigi from Kauai Community College. This has to do with the definite integral using the fundamental theorem of calculus to evaluate it. So first, we need to go ahead and figure out how to find the antiderivative of this square root of y minus 1 over y. Okay, so when we look at this right here, we would say, oh, hey, look, really cannot look at the antiderivative the way that the function is. So we can go ahead and it said all divided by y. So let's go ahead and divide it by y. Square root of y divided by y. Square root is y to the 1/2. When we divide by y to the first, property of exponent said, keep the base the same and subtract the exponent. So that is y to the negative 1/2. So this is y to the negative 1/2 minus 1 divided by y, dy. Okay, now that it's in the form where I can actually look at the antiderivative, I will say that that is equal to the antiderivative of this function evaluated from 1 over 16 to 1 over 4. So, antiderivative, go backward. So, power rule backward. So, I'm going to have to add 1. And when I add 1, I have a half. So I have to divide by a half to undo the multiply by 1/2. So that would be 2. Okay, now if we were to go ahead and check our answer, bring the 1/2 down, that will cancel with a 2, y to the negative 1/2, which is what we have there. Okay, and the antiderivative of 1 over y, and you're going to want to, I do this so often that I don't make that mistake, but sometimes I will just my brain just doesn't click and I forget that I cannot apply the power rule there because 1 over y is a derivative of ln of y. Okay, so remember that 1 over x, that's the derivative of ln of x. So upper minus lower, okay, when we evaluate. So that would be 2, and to the 1/2 is square root of 1 over 4 minus ln of 1 over 4 minus 2 square root of 1 over 16 minus ln of 1 over 16. Okay, so square root of 1 over 4 is 1/2. 1/2 times 2 is 1. ln of 1 over 4. 1 over 4 is 4 to the negative 1 power. Negative exponent can go in the front. So that would be plus ln of 4. Okay, that's a little trick there. 1/16 square root is 1 over 4 times 2 is 1/2. So I have minus 1/2. Actually, it'd be nice to just not do that and keep this here and then keep this here so you can see. Okay, and then ln of 1 over 16. 1 over 16 is 16 to the negative 1 power. ln, negative exponent go in the front, so that becomes a plus ln of 16. But ln of 16 is 4 to the 2nd power. So the 2 can go in front. So then I will have 2 ln 4. The reason why I wrote 2 ln 4 is because it's like term to here. Okay, now we could actually reduce that further to ln of 2 on both of them if we want to, but it really doesn't matter. So anyways, you know what? Let's go ahead and do that because we could. So 4 is 2 squared, so this would be 1 plus 2 ln of 2 minus a half minus 2 ln of 2 times 2 would be 4 ln of 2. Okay, so 1 minus a half is positive a half minus 2 ln of 2 is our answer. Okay, so what have we just learned through all of these computations? And I know I went through that pretty fast, but the integral is the antiderivative evaluated from lower to upper, right? Now, when we evaluate from lower to upper, that really is the antiderivative evaluated at upper minus lower. That's what the fundamental theorem of calculus said, and then you just have to go ahead and do some computation to get your answer.